Once again, my name is Viren. I'm the Education Director for BDAA, and this week we're going to do Intro to Data Visualization in R. So just a little bit of the overview. We're going to go over the workflow just to talk about where data viz fits in again, and talk about exploratory data analysis, what it is, why it's important, and then get into the packages that are used for data visualization in R, and then get into coding. So, again, data visualization is, that comes after we have extracted and cleaned the data. So this is the part where we want to explore it to look for patterns, relationships between variables, any sort of frequencies and columns, and get a sense of how our variables behave. And, we do this through data visualization and understanding how the data is structured. So a lot of times when you see data dashboards, that's all done from exploratory data analysis and data visualization. So EDA is a huge part of the data science process, and it's important, as I said, for not only finding any sort of anomalies or outliers in your data, but it also communicates any findings you have, and tells a story, right? When we see this this chart right here, anyone who isn't familiar with the whole Robin Hood and the stock thing, you could take a look at this picture and see how it affected a lot of how the current events affected Robin Hood and its reviews in this case. So that's the importance of EDA and why we do it, and we're going to get into doing that with R. But first I want to talk about, the packages that are used for it. And, the tidyverse, as I mentioned, the tidyverse is, a collection of the packages used for data science in R. They all follow a similar format in terms of, for the data manipulation one, we use dplyr. But for the focus of this workshop, we're going to be using ggplot2. And ggplot2 is a very popular package that's used from the tidyverse, and it's used for data visualization, and it can be used alongside dplyr to chain things together and to visualize our data in an efficient way. And for those of you who had gone to the dplyr or who were in the data manipulation workshop last week, 2 weeks ago, you'll see that we'll be using some of that syntax as well as learning about different types of plots. So with that, we're going to get into our data set and coding. So this is just the Michael Jordan, Kobe Bryant, LeBron James comparison per game stats. So I'm going to actually take this link and send it in the chat. And so you'll want to click on that link and download the data set here. So it's going to take you to this Kaggle. Same thing, come here, download it and save it to your files. And then for the notebook, I'm going to send this here. You guys will want to click on that link. And for those of you who are actually already in the workspace, it shouldn't ask you to join it. You should just have to log in, and it's going to show you the notebook itself. So if I click on this link here, it's going to ask me to log in. So do that here. And it's going to show in your workspace the Intro to Data Visualization in R, and you can go ahead and click on that. So I'm going to click on it here, and let me know in the chat when you guys are ready, or give me a thumbs up, and we can continue. All right, so now what we're gonna do is we're gonna get, so this is the R markdown file that we're gonna bring in here. So I like to just close this terminal down here real quick and click on this Intro to Data Visualization in R link right here, and it's gonna bring up the project here. And I did this last week, and I'm gonna do it again just because it makes it easier to read. So if you go to Tools up here, and then you scroll down to Global Options, this will give you the option of changing the way these panes are looked. So if you look at the pane layout, this source is just where you write your code. The console is where you can also write code, which we'll be making use of. And then this is your environment, which stores, any sort of variables. And here is where you'll see your plots. So I like to make my console up here just so I have it on the right side, and you can do the same if you want. Otherwise, you don't have to. So I just did this, and I'm going to apply it. And now this is over here on the right side, and just bring this down. And now we are ready to start. So first thing we want to do is you want to install the tidyverse package. And the way we do this is with the install.packages, and we pass in the library we want to install. So we did this during the intro to data manipulation one, but I'll just give a quick review. You just do install .packages and specify as a string tidyverse, because the tidyverse is the collection of all those packages, right? So we want to install that into our environment first. So go ahead and do that here. It's going to take a few moments. This red stop sign here, if you remember, means that there's a process going on. So we're going to just wait for that. And actually, as you can see, like I made you guys download the data set, but I think a nice thing about our Studio Cloud is it also just has the data set there with you. So that's good. Okay, so we've installed the packages. This stop sign's gone, so we're ready to go. So now we wanna load in 3 packages. We wanna load in ggplot2, we wanna load in dplyr, and we wanna load in readr. Okay, so the readr is gonna be for how we read the data in, and then dplyr and ggplot2 are for data manipulation and visualization. So the way we do this is we run the library function, and then we pass in the library we want to load, but not in quotes. So it'll actually autocomplete it for you if you start typing. So if you go library, and then you pass in ggplot, right? ggplot2, it shows up here. And then we're gonna load the other as well. So library dplyr, and we're gonna do library readr. Okay, so we've done that, and we're going to run it. And these are our code chunks. So this is where we're going to be writing our code. It's the markdown cell. It's between these R tick marks. Markdown is where you can just write your text. And so now we're going to read in the data frame. So I'm going to save it to an object. So let's call it df. And remember, in R we use the caret and hyphen to make an assignment to a variable. So do df and then call read CSV, and then we want to specify our file path as a string. So here you can just type in per game stats as per underscore game underscore stats .csv as a string. So we're going to do that. We're going to do per game stats .csv, and we run that, and we'll see that it has run it in. Philip, what exactly did you want me to go up for? Did you want to install the packages? The Markdown actually has the direct.
It's actually, but I just want to see the other library. This last library here is, it says dplyr.
Yeah, dplyr. Yeah.
Okay.
Yeah, it should be those 3. And so now, once you call that read CSV function, we have read it in, and now we have our data frame. And so here it shows our columns and the various different types. So the first thing I'm going to do is I want to take a glimpse of the data. So that just shows the data and their types. So let's just do glimpse data, right? So, oh, I called it df. Whoops. So let's just do glimpse df. My bad. Yeah, so df, so this again returns all the different columns and their various types and some of the first few observations. And you see here this console is getting cluttered. So what I'm going to do is I'm going to go up here to the top right. This broom will clear our output. So now I'm going to explain briefly what plotting in ggplot2 is. So plotting in ggplot2 follows a 3-step process, or essentially your plots are in 3 different layers, and I'm going to go through those layers one by one to explain how it works, and then we're going to do it with some examples. So the first layer, okay, consists of specifying what data you're going to use. So you're gonna use the ggplot function where you're gonna pass in your data frame. So that's the first argument. So df tells the ggplot function that we're gonna use this data, and that's gonna be the data we're gonna want to plot with. So this is how you would do it, right? That's the first layer, specifying the data, ggplot, and then df. And then the second layer is specifying the aesthetic mappings to the data. So what that means is that once we've specified the data frame here, ggplot knows that we're going to use this data, but now what we want to do is we want to specify the X and Y column that we're going to grab from our data. And this is wrapped in an AES function. Okay, and that's the second parameter. It's called AES because the way ggplot references the mapping of your X and Y columns is in aesthetic. Okay, and that's going to represent the data we're going to pull. So we've specified the data, and now we've specified in the aesthetics parentheses, that function, that this is our X column, this is our Y column. So now we're ready to plot with it. So once you do that, that's the second layer. And now the third layer, oh yeah, and this here, we're going to see this. Another aesthetic that you can use is the fill. That's just if you want to plot a third type of third dimension of your data, but I'll show you that later. But that's how you would specify the X and Y's. And then the third layer is the geometry function. So this is what you're gonna use to tell the ggplot function that you're gonna plot either a histogram, a bar graph, or a line plot. So here, what you would do is, we took this ggplot function, we specified the data, we specified our X and Y mappings, and then we're gonna add, right, with the plus operator, the geom function. So in this case, if I did, geom histogram, this would be the X and Y's, and then geom histogram. So that's the third layer. So the first layer, specifying the data. Second layer was our aesthetic mappings, which are our X and Y's. Third layer being the geometry function, which means the type of graph, right? And so then you can also add other things along with this. So this is the bare minimum, right? This is going to get you a graph. But let's say you want to add, X and Y labels, right? Well, what you do is then just with that plus operator, add any sort of functions. So to specify X and Y and titles axis, you just do labs, stands for labels, and then the parentheses, you pass in your X label as a string, Y label as a string, and title label as a string. So you can see the three layers here, right? You got your data, your X and Y mappings, the geometry function, and then anything extra you add. So like the X and Y labels. And so then you can also even add it. Let's say you want to add a theme, then you just do plus, and then here's an example of the theme. We're not going to get into themes that much here, but this is pretty much the extent to what we're going to be doing today. So I mentioned dplyr as well, and you can also specify that first layer with dplyr syntax. So here we specified the data as the first parameter. We just wrote that in, but you can also use the pipe operator and make df the input into that function. So this, remember, if you remember the pipe operator, this says that the df is piped into the ggplot function as the first argument, and then the rest carries through. So I'm going to be doing it like this, but as you'll see, you can also specify it like with the first parameter, and you'll get the same results. So with that, we're going to now talk about visualizing distributions, right? So visualizing the numeric distributions is, one of the first few things I like to do with exploratory data visualization, because you want to see what kind of, how your data spread out, right? What kind of observations are, and you try to find any anomalies in the data. So there's going to be 3 different plots I'm going to show you. I'm going to show you a histogram, a density plot, and a box plot. So to plot a histogram in ggplot2, we follow that same formula, right? So we wrap that, we call the ggplot function, pass in our data. And in this case, right, I said X and Y mappings, but that could change. In this case, this is a histogram, right? So your histogram is going to take your X numeric variable and plot the frequencies associated with that, right? Your Y is just going to be the frequencies of, or the spread of your X column. So in this case, you only have to specify that X variable, that X mapping. So the data, the X mapping, and then we specify the geometry function, which in this case is a histogram, okay? And if you want to specify the color of that histogram, you just pass in fill and the color as a string. And then X and Y labels is the X and Y, so with the labs function. And then this is identical to if you use the dply operator to pipe the df data frame into ggplot function, and it carries through. So we can also, bin width is another thing we like to tweak with histograms. Bin width just changes how many, how the appearance of your histogram looks based on the intervals, because each interval stores the, the amount of observations. So that's just going to be a additional parameter in your geom histogram, where it's just a numeric. So let's go ahead and let's plot some stuff here. So plot a histogram of the distribution of the 3-point percentage filled in red. So one thing I like to do is run this col names function so I can get the columns. And so now let's do ggplot, right? I'll show you how to do it the first way. So I specify the data frame, right? And then I go AES, right, to say what our aesthetic mappings are. In this case, it's a histogram, so I'm only going to do the 3-point percentage, right? So I'm going to do X, and then in this case, since 3-point percentage is a character that it can't really recognize, you want to wrap that in backticks like we did before. So you just do some backticks and do a 3-point percentage, and then we do plus geom histogram. And the color is, we fill it with the color red, and we're going to label it. Actually, let me just, I'll run this here. Let's just show you what it says. So now this is our histogram. So now let's say I want to label it, right? Let's just do labels, and instead of labeling it count or the Y instead of count, let's just do X equals observations. So it labels it by default, but if you wanted to customize it, you can do so. And then title being the distribution of 3-point percentage, right? So now if we run that, we see we have our histogram here. So, we can see from the distribution of 3-point percentage amongst Michael Jordan. So this is taking all of the players into consideration. So there's probably someone who, so these are per game stats, right? So this right here, this outlier here could indicate that maybe one of the players had, a game where he shot 1 3-pointer and made one, right? So this is something we want to consider. And so now let's plot a histogram of the free throw percentage. So same thing. Specify your data, your aesthetic mapping, which is going to be the free throw percentage, right? Wrap that in backticks, and then we call it geom histogram and fill that with the color blue. I believe that's what I said. And then we are going to label it accordingly. So just call it obs frequency, and the title being the distribution of free throw percentage, right? Let's run this again. So now we have, so see here that this is what our histogram looked like by default. But now let's adjust the bin width to see if we can get a better shape here, right? There's a lot of gaps here. It's kind of hard to interpret. So I said here specify bin width of 0.05. So again, to specify the bin width, we go to that geom histogram function and we add an additional parameter called bin width. So it auto completes it for you, and we're going to do 0.05. And if we run that, so now this is a nicer shape. So the bin width is a nice parameter you want to tweak with histograms. So now let's do the last one, just plot a histogram of the turnovers. So df AES. In this case, there's no characters that we have to worry about here, so we can just do TOV as normal. R is gonna recognize that. And then we can do geom histogram, same thing. I filled it with green with a bin width of 0.5. And in this case, let's just do labs. For the sake of time, I'm just going to copy and paste this. So you can Control C, Control V, the labs. So you just write labels and then distribution of turnovers. So that's our third histogram. So now this is our, this shows our observations of our turnovers. So we can see, we'd have to do some tests for normality, but we could, say it has an approximately normal shape. So that's the nice thing about histograms, is that you can look at the shape and kind of interpret it. But the thing is that sometimes histograms have a lot of, it's hard to, you want to see like a nice smooth curve sometimes, just to see the overall shape. So that's where density plots come in. So a density plot, to do that, is the same thing as the histogram. Literally all you have to do is just do geom density instead of geom histogram. So let's do that here. So let's plot a density curve of the distribution of 3-point percentage. So I'm going to go through the same exact stats as before. This time let's do it the dplyr way. So ggplot AES, X being the 3-point percentage. And then let's do geom density being the fill, being red. And then let's do labels being the observations. And then the title being the distribution of 3-point percentage. Right? And then if we run this, we see here that this is a nice curve. So, we got the distribution from the histogram, but this shows a nice curve and how it's spread out. And so let's do it. Let's do it again. Let's do the free throw percentage. So free throw percentage, and then the geom density being blue here. And then if we run this, now we see this shows a nice curve as well. So as opposed to our histogram, when we didn't specify the bin width, it was hard to interpret. This curve comes in. And then just again, let's just try, and let's see how the normal shape looks with the turnovers. So let's do geom density and then fill green. Of course, you could also specify your X and Y labels here. It auto generates it, but if you want to tweak that, you could just use that labs function and concatenate it. So here we can see, it has that mound, that bell curve shape. So that's densities and density plots and histograms. So now let's look at box plots or box and whisker plots, right? These are another way of visualizing your distribution. So, the same thing here. Only thing we have to change is geom boxplot instead of the other functions. Everything else stays the same, but it's really good at finding outliers in your data. So, let's go ahead and let's check this out. So let's plot a box plot of the distribution of points. So let's do ggplot df, and then let's do AES, and then just to show you the column names I'm referring to. So I think it was points, I believe. So it was X equals points. So X equals PTS, and then geom boxplot. So we do that, and let's fill it red. And then let's add axis labels here. So X equals the points, and then let's do Y equals spread, and then the title being the distribution of points, right? And if we run that, we get our box plot here. So, we can see quite a bit of outliers to take note of. So these are per game stats, right? That's something we want to keep in mind as we analyze our data, like in what context are these stats? So these are collective stats from Michael Jordan, LeBron, and Kobe. So this is our full distribution. So we can see here that someone was averaging 40 points a game. But however, there's one column we see here called RS or PO. That's regular season or playoff. So this data was collecting stats on them per game for the regular season per game stats as well as in the playoffs. So this could be anyone which we could identify and explore. Similarly, someone was not having so much of a good performance. So that's something we could explore as well. And so let's do one more. Let's do the total rebounds filled with purple, and the distribution of the total rebounds here takes into account the offensive rebounds and the total and the defensive rebounds. So if we go TRB, that's what the total rebounds column is. We go geom boxplot, and we fill it purple. And let's just do that for now. And yeah, so that's how you do box plots with ggplot2. So that was a visualizing our distribution via histograms, density plots, and box plots. You generally want to do this with your numerical variables and continuous variables to just see what the distribution is like and identify any outliers. So now we move on to So now we move on to categorical comparisons. So you have your numerical columns, but you also want to observe your your categorical or discrete variables. So those consist of a couple different values. So here RS or PO, that's reference to either regular season or playoffs, right? Those are categories, or anything which is category you want to explore to see how your numerical variables may change across those. So we're going to now kind of look at our numerical columns in the context of those categorical variables and see how they change. So here, let's plot the box plot again, but now we have this fill argument here. As another parameter in our aesthetics. So what this is doing is that, remember, our aesthetics specifies the mappings from our data onto the plot. So here we're specifying that X column, and then we're going to map that discrete categorical column onto it, and you'll see what happens, and it's pretty neat. I use this a lot, and it's a good way of visualizing your data. So let's plot a box plot of the distribution of points, just like before, but in this time, specify the fill argument with the RS or PO, or regular season or playoffs, and let's see what we get. So let's do df ggplot2, and let's do our AES, and let's specify the points column again, and our fill argument with the RS or PO column, so regular season or playoff, and let's do geom boxplot. And this time we're not going to specify a fill because we filled it with the aesthetics. And then let's do the labels as the observations, and Y being the spread, and title being distribution of points. So now if we run this, right, as opposed to what we had before where we just did the point distribution, so we were seeing all of our players. If we run this, we see all of our players, but now we can kind of see the difference between how these players performed in the regular season versus in the playoffs. And, we can see here that generally most of our players were a lot of, Michael Jordan, LeBron, Kobe were known to be very clutch performers when it came down to the playoffs. So it's no surprise that maybe, the amount of points they had was higher in the playoffs. But also conversely, you could think about, in the playoffs, they play, they may have been playing more minutes, and that's another reason to explain that. So taking, using this regular season or playoffs categorical column was important in helping us decipher that. So let's plot a box plot of the distribution of assists filled by player and label the axis. So now we're going to fill it by the player. There's 3 players, so that's another category. So let's do ggplot2, and let's do AES, and we're going to do assists, AST, that's the column, and then we're going to do fill by player, and then we're going to do geom boxplot, and then I'm just going to copy this here just to save time, and then let's do distribution of assists. So now let's observe this, right? This was our original, we just did it by assists. If we did it normally, we'd get everything. But now here, this is a very good plot because we can see how the distribution varies amongst the different players. So now we're not looking at the distribution as a whole, we're splitting it up by each player. So we can see that, we can conclude from this, and after some more analysis as well, that LeBron James tend to be a person who like to share the ball more than the other 2 players. And Kobe Bryant seem to share the ball less, as opposed to if you look at their medians, middle values. So this is a good way. That this fill argument is really good when you're plotting your visualizations, because it can help you explore such things and explore your data deeper and the relationships between them. So that's the box plot. So we just visualized our numerical columns like that, and then we got into the categories and how we can split them. But now we're going to actually get into visualizing these categorical columns as well with bar charts. So a bar chart will help us, look at the frequency of these various columns, and again, look at how they vary against the players or the regular season in this case, or any sort of categorical columns. So to do this in ggplot, the way you do it is the same formula with your data and the mappings, except in this case, the first way we're going to do it is we're going to specify the geom col and the fill being the color. So in this case, we're not specifying that fill aesthetic here. We're going to be just coloring the bar chart itself. And in this case, since it's a bar chart, right, you need an X column and a Y column to plot it, because you're plotting frequencies. And the X column, right, so we're gonna plot a bar chart for the 3-point percentage that varies by each player. So our players are going to be our X, and our 3-point percentage is going to be our Y that we're trying to compare. So let's do this here. Let's ggplot2 df, and let's do AES, and let's do player, and then our Y being the 3-point percentage, and let's do geom col, and let's color, did I say fill red? Did I say red? Probably. And then let's label that with the axes. So let's do players, and then Y being the 3-point percentage, and then let's do title being comparison versus comparison. And then let's run this. So now we see here, we get a bar chart here comparing the 3-point percentage between Kobe, LeBron, and Michael Jordan, right? So we can see here that Kobe was probably had higher 3-point percentage, but again, we don't know in what context, whether this was regular season or playoffs or when. So we would want to explore that. So now let's do one more. Let's do a couple more. Let's plot the bar chart for free throws for each player. So same thing, df, and then the AES, x equals the player that we are comparing, y equals the free throw percentage, and let's do geom col, a fill with the color green, and then let's now add our axis titles here with the labs function, and let's do free throw percentage. So edit this free throw, and now when we plot this here, we can see that also we can compare the free throw percentage. It seems like Kobe Bryant was better free throw percentage as well, and better than LeBron and Michael Jordan. So that's comparing the free throw percentage, and then we can also again with the bar charts, we can also use that fill column to look at how it varies, which we'll get into. But let's look at the points varying by the regular season or playoffs. So let's do ggplot2. Let's do df. And in this case, we're going to specify our X column, where in this case, we're going to reference the RS or PO, the regular season or playoffs column. And let's use that as our X, and then use points. And then let's do that with the color purple. So fill purple. And then, let's take these labels and then tweak the points, right? The points. And then this will be the regular season or playoffs. So when we plot that now, we can see that we can compare, the amount of points that were scored more in the playoffs or regular season. Again, this takes every player into account. It doesn't tell us much, but we can see that, it would make sense that more points are scored in the regular season, right? Because you just play more games in the regular season. You play 82 games. So this is how you do basic bar charts. But now we want to maybe use the fill argument to look at how other columns play a role in this. And we can do this with stacked bar charts. So again, with here, we specify that geom call because we're doing a bar chart, labels as usual. But in this case, in our aesthetic function, we're specifying that fill argument and using that column 3, which is our third column, which we're going to be plotting or mapping. So now what we're going to do is we're going to compare the 3-point percentages of the players like we did. But this time we're going to be filling it by the regular season or playoffs to see how did they perform differently under different situations. So let's go df and then specify the first argument, and then the aesthetics being the player, right? And then y being the 3-point percentage. And then our fill argument being the regular season or playoffs. And since we're already filling in the aesthetics, no need to specify the color. And then the labs being the X equals the player. And then Y being the 3-point percentage. And then the title being, let's just do comparison. You'd obviously make it more descriptive, but in this case, let's just go with that. And then let's just run that. So now here we have our stacked bar chart. Right, and this is much more interesting to us because it can see how they stack up kind of against each other. How did Kobe Bryant shoot or 3-point percentage versus the playoffs, versus the regular season, right? We can see that Michael Jordan tended to have higher 3-point percentage in the playoffs. He was a clutch player, no doubt about that. But let's do this again with the free throw percentages, right? Because that's also an interesting stat we like to look at. So let's do ggplot2, let's do AES, same thing with the player, and y is equal to the free throw percentage, and the fill is the RS or PO, right? And let's do geom call, and let's pop that. So now in this case, we can look at free throw percentage, right? How did it vary? So it seems like Kobe Bryant shot a bit better in the regular season. But the thing is that these stacked bar charts are good because you can look at the different variables, but it's kind of hard to interpret sometimes when you have your different proportions relatively close together, right? We can't really tell for sure if this was 50-50 for Michael Jordan or if something was increase or if one of the proportions was greater than the other. So a way to kind of make this plot a little bit more visually appealing and easier to interpret is with side-by-side bar charts. And the way we do that is, we will use that same fill argument to specify the specific column we're going to be mapping, but we want to instead, in the geom call function, we're going to specify an argument called position. And this will tell ggplot how the columns are going to look on the graph. And the specific string you want to pass is dodge. So dodge is just what you put into tell ggplot that the bars are going to be next to each other, but everything else stays the same. So we're going to plot the same exact graphs for 3-point percentage and free throw percentage, but you're going to see how it differs with that position function or position argument. So let's do the same thing, ggplot2. We're comparing the, we're putting in the data and then AES and comparing the player, right? And then the 3-point percentage. And then the fill argument, fill by the regular season or playoffs, because we want to compare those. And then do the geom call, but in this case, we're gonna put that position argument and we're gonna write a string called dodge and then label the x-axis. So player and then y being 3-point percentage, right? And then you would also put a title. So in this case, this is a lot easier to interpret versus the other one, right? You had our stack bar chart, it was good, but this is a lot nicer because it shows those categorical columns right next to each other for a given player. So we can see here that Michael Jordan, and the thing that stands out is in the playoffs, his 3-point percentage is way higher. And we can see that LeBron James he was close 50-50. And we saw earlier that LeBron James had a higher spread of assists. So that could also explain why his 3-point percentage is a little low, because he might have been taking less 3-point shots. And we can see here Kobe Bryant, shot a bit better in the playoffs as well. So this is what I like about stacked bar plots, because it's easier to visualize those categorical columns. So now let's do the same thing with free throw percentage. Let's do ggplot, specify that df, and then instead we're going to do the free throw percentage like we did before. And let's do y equals, in backticks, free throw percentage, fill by the regular season or playoffs, and then geom call, and then pass in that dodge, right? And then let's get the labels, the X and Y labels, but let's see, let's actually specify a title. Let's just do compare player comparison. So now we can see with the free throw percent, I labeled it 3-point percentage. Whoops, my bad. It's free throw percentage. So now we can see our free throw percentage comparison across the various players. All of them were clutch free throw shooters in the playoffs. So that makes sense, because the playoffs is where free throws need to be. You need to be on your best game there. So this is stacked bar charts with ggplot, and this is something I use a lot. And I think is very powerful with this position dodge argument here. So now we're going to get into horizontal bar charts. So visualizing it like that is great, but sometimes you might also want to visualize it horizontally. And the way we do this is, it's simple. All you really have to do is, you keep the same exact setup, but all you do is just add you concatenate an extra function called chord flip. So what chord flip does is it's gonna flip the axes. So your y-axis are going to be your players, and your x-axis are going to be your counts for your numeric variable. So there's not much to really change here. So we're gonna compare the defensive stats here. So let's compare steals amongst different players filled by regular season or playoffs, and the dodged position. And to make it horizontal, we're going to do chord flips. So let's do ggplot, and we're going to do df, and then AES being the player, y being the steals. So that's STL, right? We have STL here. And then y, or fill, being our regular season or playoffs. And then we're going to have the geom call, with the position being dodge, right? And then we're going to chord flip it, right? Because we want to make it the other axis. So you would do that, and you can also add labels if you wanted to as well. But now once we do this, this shows the bar chart the same way, but just in an alternate format. But this can be easy to read as well. It all depends on your preference. But we can see here how the players stacked up when it comes to defense in this case. So we can see that LeBron James was a better defender in the playoffs. It seems better than the other two. He had a higher amount of steals. And in this case, Michael Jordan, Kobe Bryant had the same falling trend, but it seemed like Michael Jordan was a better defensive player than Kobe in that regard. So that's one thing which is good. And let's now plot a horizontal bar chart with the blocks. So really, I'm just gonna actually just copy this because it's the same exact thing. All we're really changing is the block argument for the Y. So let's go ahead and make this BLK, right? That's what blocks are in our data. And you could even get that with, if you just, just did that. And so let's plot that. So let's run it and we get the blocks. So wow, yeah, it seemed like, wow, Michael Jordan was, wow, okay. So they all were had a high frequency of blocks in the playoffs versus the regular season. So that's one thing to take note of. Seems like that Michael Jordan and Kobe Bryant may have not been the best on-ball defenders because they had less steals, but they were probably really good around the rim because of their blocks. So let's also look at the turnovers. So let's do ggplot AES x equals player, y equals TOV for turnover, and fill by regular season or playoffs. And let's go geom call position dodge and chord flip it. And then we run that. Oh yeah, and also I've been running that entire markdown cell, but what you can also do is, remember, you can highlight this, and if you go down to this drop-down menu, you can just click run selected lines. So it just runs that one. So it's not going to show all of them, but just this one. So here we can see that when it came to turnovers, Kobe was really keeping, making sure he was keeping track of the ball in the playoffs and had less turnovers versus the regular season. So, he was playing more efficiently, and versus the other two, the trends are similar. So that's horizontal bar charts in ggplot 2 and bar charts in general. So those are the different ways you can do that. But now another thing we want to do is, we've looked at the distribution of our data, right? We've seen how it is shaped, what kind of outcomes it has. We've looked at the various categorical columns. We've plotted bar charts to see how they map against each other. But, you also want to look at the relationship between your numerical variables, and scatter plots help you do this. And scatter plots are a huge part of exploratory data analysis. You can use this as a baseline for what kind of variables you want to include in upcoming models. It's big in linear regression. So being able to plot these is really important. And so what you want to do here is, since you're you're comparing the relationship between two different columns, you're going to have an X and Y aesthetic. And then instead of, your geom function is going to be geom point, right? And you're going to add your X and Y labels, right? Simple as that. So let's plot a scatter plot to explore the relationship between assists and turnovers, because assist to turnover ratio, any of you guys who play basketball or know about basketball, that's a big statistic that's used in basketball. So let's look at ggplot and specify the df data frame, X being the, let's do assists, and Y being the turnovers, right? And let's do geom point. So since this is gonna look at the relationship in general for all three players, because, and then let's add the labels, and let's do assist, right? And Y equals turnovers. And let's do title being assist versus turnovers, right? And so let's visualize what we get. So we see a somewhat of a positive relationship between the two. And this should make a little bit of sense, because if you have more assists, that means you're attempting to pass the ball more, which means you're more likely to turn the ball over more as you attempt those assists. So assist to turnover is one of those statistics that are highly regarded, and this makes sense why the assist to turnover might be positively correlated. But of course, you would have to do some analysis to make sure that it's actually significant relationship. So let's do it for I guess I didn't change these directions. Okay, let's just do it for the steals and points, right? Let's do that. Let's do df, and then let's do AES being the x equals the steals and y equals points, right? Let's see if there's any relationship between the defense to getting steals to scoring more points. And let's do x being the steals, that is string, then y being the points, and title being steal versus points, right? So let's highlight that and then just run selected lines. And then we can see here that this also has somewhat of a positive relationship. So, this can make some sense, right? Because steals in the game of basketball, if you're an on-ball defender, it could lead to fast break points. So, if you have more steals in a game, that could lead to more points. And this is per game. So that's something interesting we could look into. And then another thing, let's do one more. Let's just look at the the assists versus, or no, let's just do points versus free throws. Yeah, I don't know. There's probably not going to be much of a relationship there. Or let's do x equals free throws, and then y equals points. Right, and let's do g on point. Yeah, and then you can label your x and y's, right? And then this does make sense, because if you obviously score more free throws, you're gonna have more points, right? Yeah, that's the data visualization course for today. So the three main things, right, that we want to do in exploratory data analysis is explore the distribution of our numeric columns. We want to look at how they scale versus the categorical columns. We want to look at bar charts to plot the frequencies, and then look at the relationship between numeric variables to investigate their relationship between each other and try to come up with some sort of reasoning to explain why that may be. So that is the intro to data visualization in our workshop for today. If you guys have any more questions, you can stay after and ask, or feel free to send me a message on Slack. And then, yeah, also, maybe even get your own data set and practice some of this as well. So, yeah, thanks for coming out tonight.